Good evening, class. Today we will do numericals based on parallel combinations. As we all know the formula of parallel circuit, that is, yesterday I have told. Okay. Yes. In this case, this is known as parallel plus series. Okay, so in this case what we'll do, we can also use formula, that is this formula, we can also use it. Okay, so we'll start doing numericals. There is one question: two resistance, one of 30 ohm and another of unknown value, are connected in parallel. Okay, the total power dissipated in the circuit is 450 watts when the applied voltage is 90 volt. Find the value of unknown resistance. So according to this question, we can draw the diagram, circuit diagram. How we'll do it? Let's see. These diagrams are too common in parallel combination. This is denoted as I1, this is I2. Okay. Power dissipated. Power dissipated in the circuit P. It is given already 450 volts. Voltage applied across the circuit. Okay, these are given in the questions. How you will solve this question? Let's see. Okay. We consider as P1. Yesterday I have given formula for power also, but here it is written, oh sorry, V square. that it is given R1 and R2, or we are finding R1, so we will write R1 over here. Just put the values. What will get? Calculate 90 square plus 270 volt. Sorry, watt. Okay. Just you have to remember this diagram. Diagram is most important in circuit diagram. You can also solve it on fingertips. Now because only value of one resistance is given, second was unknown. Okay, so what will come? P is already given 450. Previously I have written over there values. Thus the value that is R2. Put value on this formula. V square is given. P2 is 180. So what will come? 45 ohm. This is the final answer. So if you remember that diagram, there was two resistance in series. Okay, one it was given 30 ohm. We have to find this one. If you have drawn that diagram, just write the value of R2 over there. Okay, now we'll go for second question. Question is there, two resistance, four wires of same material. Okay, four wires are given of same material, the same cross sectional area and the same length when placed in parallel give a total resistance of, means R total of what? If the same four wires are connected in series, what will be the effective resistance? Okay, we have to find this. All these are joined in parallel, so we got our total of 0.25 ohm. Okay, we have to just remember these things. This is for parallel. So now we'll start solving this question. When 4 wires of each resistance R are connected in parallel, the equivalent resistance will be, see, note down this one. What we'll get? Simply we'll get R by 4. No? It is previously given that we have to put R as 0.25 ohm or 4 connected in similar wires. So we directly write it. These things just put it over here. Now what we'll get? 1 ohm. First part is completed. Now we have to find this. Connected in series. Everyone know that if any resistance connected in series, we will write like this: R1, R2 plus R3, whatever it was. So we know that it was given only 4 resistance, so we will directly will write 4R. Again we'll put the value 4 into 1. This question was simple. We have to put eyes on questions so that we will not miss a single point. We'll go with next question. Okay. A lead wire and an iron wire connected in parallel. Their specific resistance are in the ratio 49:24. The former carries 80% more than current than the latter, and the latter is 47% longer than the former. Determine the ratio of their cross sectional area. Okay, this is the main question. Little bit hard, but we'll solve it. So in this we have to assume something. What? Okay. This iron and lead. Not clear, no? PB and F you can also write. So what it is given, that is length or no? Okay, this length. Specific resistance as in ratio. These things are given in question. So since in parallel combination current in individual resistor is proportional to its conductance, you have to remember this. Okay, so in this case we will go for this formula and told you na today I will deal with formula, but okay, tomorrow definitely we will give you, I'll give you some formulas, basic formulas. Just put these are cross sectional areas. Just cross multiply it. L2 by L1. Should I solve it or just write answer? Okay, let me solve this. So what we'll get 1 by If you have doubt in this question, then you can comment it. I can again solve this question. Okay, we'll go for next question. The resistance of two coils. The resistance of two coils is 25 ohm. When these are connected in series, and 6 ohm when connected in parallel. Okay. In series and 6 ohm in parallel. Determine the individual resistance of the two coils. Okay. For R1 and R2, we have to find both. See. Solve it by making it as a question. This is that formula for direct parallel. Okay, just put value. No, you can't put value. No, you can only write 6 ohm over here. Multiply equation 1 and 2. What we will get first, let me see. R1 plus R2 will get here only 150 and R1 plus R2 is in series, so it is 25 square. R1 R2 we got as a 150. Just put the values, we'll get what? Get 5 plus minus. So solving these equations, fourth one, this is third one, we got the value. Okay, now from this equation and fourth one equation is this one, R1 plus R2 and R1 minus R2, what we will get? And got it? Okay class, for today this much only. One more question will do. Or I can just tell you how to do, or let me solve it. This is combination question. Question is given. Or by diagram I will give you the solution. See, one question is there. Two resistors connected in parallel and third one is in series. This you people will do as a homework. I'll see in comment how many of you have got the answer. And current through this 15 ohm, that is 3 ampere. So you have to find what? The current through 20 ohm as well as 30 ohm also. Voltage across the whole circuit. And total power consumed. I'll solve this question tomorrow. That's it for today, and tomorrow we'll do few formulas. Okay, till then, goodbye.